Good evening once again, all of you. As you know, yesterday we have experienced a wonderful session by Professor DHAVAL MAHETA sir, again a great academician. And today also Professor DHAVAL sir is taking the session on the second day of this workshop. I welcome you once again, sir. DHAVAL sir.
Thank you.
Over to you, sir. Over to you, sir.
Okay. Am I audible and PPTs are visible?
Yes, sir. PPT is visible and you are audible, sir. No problem.
Okay, fine. So today's session, we are going to talk about the logistic regression. Before we understand the in a statistics way logistic regression, let's try to understand this thing in a very, very simple way. Okay, I'll give you some examples to this which are related to this. Is a catalog company wants just can you remove all these things, people waiting in room C, waiting room and all that?
Sir, because you are the co-host, so ये मतलब दिखेगा ये आपको.
Okay, ठीक है. Okay.
अच्छा सर, इनको एक announcement भी कर दीजिए. वो second day ये सोच रहे होंगे exploratory factor analysis.
हाँ. Okay, so today we have rescheduled the session because of some contingency planning. I am taking the second day sessions. On third and fourth day, Hitesh sir will be talking about, means tomorrow and day after tomorrow, Hitesh sir will be talking about exploratory and confirmatory factor analysis. Nothing will change except the days we have rescheduled it. Okay, so
sir, can we take one or I think somebody wants to ask.
Sure. Why not?
Yeah. Ramesh Chauhan ji, please. You can ask. You have raised the hand. Is there anybody who wants to ask something to sir for if any query for about yesterday's session also they can ask. Ramesh ji, your mic is not open. I have not seen your mic. Only video is open. Video link is.
Yeah, Kavita ma'am is there. Kavita ma'am, I know some of them. Kavita Panjwani.
Kavita ma'am.
Are you there?
Yes, ma'am. Kavita ji, please unmute yourself.
How are you, ma'am?
Yes, sir. Yes, sir. I'm fine, sir.
Yesterday you attended the session?
Yes, sir.
Okay, fine. There are some few names I know. Then there is this Sukhmani ma'am is there. Sukhmani ma'am. She's not there. Mayua ma'am is there. Ujjain is there. Ujjain?
Ujjain sir is there.
Ujjain, how are you? Okay, fine. So we'll start today's session.
Hello, sir. Kamal, sir.
Yes, sir. Ujjwal, sir. Yes, sir. Please tell me.
Yes, sir. I'm fine. Thank you, sir.
Yeah, fine. So let's try to understand the examples of the logistic regressions which are there. A catalog company wants to increase the proportion of mailing that results in sales. A doctor wants to accurately diagnose a possibly cancerous tumor. A loan officer wants to know whether the customer is likely to default. Now here today we are going to talk about logistic regression. In that also we are going to talk about the binary logistic regression, right? There are like multinomial regression is there, then ordinal regression is there, and regression has got a very vast family. Now what in case of logistic regression, the target variable is normally in the category of 1 and 0. It's a binary 1 and 0. Now I'll give you an layman example to this. Is that suppose you are having a fever. Okay, now you are having a fever and you approach to a doctor. So the first thing which the doctor will ask about is that is what are the symptoms which you are having related to the disease, and you will say that I am having a fever. So naturally, by just saying I am having a fever, a doctor will keep a set of disease, say for example, which are n set of numbers. It is a huge number that there can be so many possibilities that why you have got the fever. But now the doctor will ask you some questions that is are you getting the fever in some pattern? Then you will say yes, I'm getting in the pattern of 8 hours. Okay, so now the set of the disease which the doctor has considered will shrink. Possibly now he will say that okay, out of the infinite set of the disease, possibly there are 10 diseases which may be possible considering the first symptom. Now second thing he will ask to you is that do you have the headache when there is a fever? Then you will say yes. So now that 10 number has again shrunk to 5 or 4. Then again he will ask you a question that do you feel nausea? Then yes, you would say. By asking this question, what he is trying to do, he is trying to narrow down the set of disease, and in last he will approach to possibly 1 and 0, that the possibility is either you are affected by malaria or you are affected by the typhoid. So by considering some variables, now it is very clear that the set of the disease has shrunk. So whenever your target variable is in binary, purchasers, non-purchasers, smokers, non-smokers, buyers, non-buyers, then in such scenario we are using logistic regression. Logistic regression is totally reverse case of t-test. Why it is a reverse case of t-test, I will explain. That thing is that in the case of t-test, the dependent variable is running in the continuous scale and the independent variable is running in the categorical scale. Please be with me. I am repeating again. In case of t-test, the dependent variable is running in the continuous scale and the independent variable is running in the categorical scale. But in the case of logistic regression, the dependent variable is running in the categorical scale and in the independent variable can be in continuous or categorical scale. So it's completely a reverse case of t-test. Normally, the logistic regression is a classification problem. Logistic regression is also considered to be the first window in the machine learning. Okay, if I teach the same subject in machine learning, the same concepts will be there, but a different angle of testing and training and all that concepts will come into the picture. But it is a first window. It is a best algorithm which is considered to be the best algorithm which can be easily interpreted, and therefore more and more people rely on logistic regression. Even in machine learning, 70% of the problems are solved by using logistic regression only because it is the algorithm which can be easily understood. It is not a black box system. It is not a black box system. The algorithms which are black box systems are neural networks, and they are all black box system in which we cannot see what is happening in the system. We cannot make the equation, and therefore the logistic regression is considered to be the best algorithm for the classification. Regression analysis is for prediction. Logistic regression is for classification. Though they are regression, the set of objective is different. Okay, let's move ahead from here. There is a difference between logistic regression and discriminant analysis is that the discriminant analysis is a parametric test. By now you know what is a parametric test. The parametric test is applicable on those variables which follow the normal distribution. So discriminant analysis, if we achieve the multivariate normality, then we are using discriminant analysis, and if we don't achieve the normality, we are using logistic regression. Both will give you the same result. Yes, both will give you the same result, but then also logistic regression is more preferred over discriminant analysis because logistic regression gives you the equation. Discriminant analysis does not give you the equation, and that's the reason we are using logistic regression more. Now see the example here, all of you, and again my all PPTs are connected with the dots. So there is, in the end you will come to know that what is happening in this algorithm. So please pay attention here that what how this algorithm is working. Now, say for example, there is some data set in which there is a purchase and non-purchase, male and female. It's just a hypothetical data which I have created, not downloaded from anywhere. No, I have not collected the data from anywhere. This is just a hypothetical data. So for a particular brand, purchase or not purchase, male and female data set is given, and that's like this is a frequency table. Okay, it's a frequency that 34 male will purchase this product and 25 will not purchase. Female 23 will purchase this brand and 27 will not purchase. So now let's convert this thing into the percentage. And how can I convert this thing into the percentage? It is very simple. 34 divided by 57, 23 divided by 57. Okay, and how can I convert this thing into this thing also into the percentage? 57 divided by 109, 52 divided by 109. Again, this thing 25 divided by 52, 27 divided by 52, and 52 divided by 109. This also 59 divided by 10, 50 divided by 10, and we get the percentages. Okay, we get all the percentages. Now let's see what's happening. Okay, we will go on the screen many times. Odds ratio, purchase to not purchase, purchase to not purchase. Let's go back. Purchase to not purchase. What is odds ratio? Purchase to not purchase. Okay, so let's go back there. So purchase to not purchase, 0.52 divided by 0.477. Okay, so what I got? 1.049 divided by 1. Okay, now conditional odds for male, purchase to not purchase. Okay, for male, purchase to not purchase, 0.596 divided by 0.480. Okay, so 1.241. So if we consider purchase as a success, then the probability of happening this event is more in male. Okay, if we consider the purchase as a success, then probability of happening this event is more in male. Let's talk about the female. For female, purchase to not purchase. Okay, purchase to not purchase. Let's go there. 0.403 divided by 0.5. So you get 0.806. So if we consider the purchase as a success, then the probability of happening this event is less in female because the odds are less than 1. If the odds are more than 1, then this event will happen. If it is less than 1, this event will not happen. Wait a minute. Wait a minute. All your interpretations will come from what you are coding as 1. Remember this thing. If you code not purchase as 1, your interpretation will come that way. If you code purchase as 1, your interpretation will come that way. So make it sure what is a success in your event. I'm again repeating, what is a success in your target variable you have to define. Okay, for example, if I say buyers and non-buyers, so buyer is a success and I will code it as 1 because each and every interpretation in case of logistic regression will come from the point that what you have coded as 1 independent variable. So if we consider purchase as success, then the probability of happening this event is less in female. Overall odds ratio. Okay, overall odds ratio is what? 0.522 divided by 0.477. So I'm getting 1.539. Now see, males are 1.539 more likely to purchase this brand than females. This is just a hypothetical data. Okay, so males are 1.539 more likely to purchase than females. Okay, let's try to understand this thing by again the graphics which I always use to make the things very simple. Okay, now see, this is odds ratio, the probability of happening the event, probability of not happening the event. Okay, see, again I'm repeating, probability, okay, of happening the event divided by odds is what? Odds is just how much the event, how many times this success has happened, how many times the failure has happened. Success divided by failure. Okay, buyers divided by non-buyers, smokers divided by non-smokers. Okay, then what is the probability? So the probability is the success divided by success plus failure. Okay, what is the probability? The success divided by success plus failure. What is the probability of failure? Failure divided by success plus failure. Okay, so this is the way we are interpreting. With this interpretation, let's try to understand. With this interpretation, let's try to understand. What I want to say is, if the probability of success is 0.80, then we know that the probability of the alternative outcome is 0.20, because we know that all the probabilities have only one, the total is 1. This probability means that odds of success are 0.80 divided by 0.20. 0.80 divided by 0.20. That is, success is 4 times more likely to happen than failure. Conversely, we can say that odds of failure as 0.20 divided by 0.80, which means that the chances of happening failure is 1/4 rate of the success. This is odds, and your interpretation will come on this way. Now, what is the difference between linear regression and logistic regression? The difference between linear and logistic regression is that the dependent variable in case of logistic regression is coded as 0 and 1. Now all the problem germinates from here only. Why? Because yesterday we saw one thing, that the error should be normally distributed. Is it clear? Error should be normally distributed. But in case of logistic regression, now the error will not be normally distributed. It will be distributed binomially. Now many times people say that, sir, we are doing the courses of data science, and we do we require statistics or the knowledge of algebra? Of course you require the knowledge of basic statistics, because in this case we are using the probabilities, we are using the algebra like matrices and vectors. We require the knowledge of this, but you don't require very advanced knowledge. You require a basic knowledge of matrices, because in factor analysis, tomorrow the sir will be talking about the matrices, eigenvalues. All these are concepts which you should know. They are coming from the background. Those who have studied the field of science, they know very well know that this is coming from that background. Okay. uh, Second, the variance of dichotomous variable is not constant, creating the instances of heteroscedasticity. Now you very well know what is a heteroscedasticity and homoscedasticity. The desirable is homoscedasticity. The yesterday's example was that the error should be like a ECG. Okay, it can fluctuate. It should be range bound. The fluctuations are allowed in range bound. Okay, but the possibility of a very large error should be very small. Very large positive error should be very small. The possibility of the very small negative error should be very small. And this is the reason we are not using linear regression when your dependent variable is in categories. Logistic regression derives its name from the logic transformation. We are converting our equation to log transformation. What is a log? All those who are coming from science background, they know what is a log and how it's working. Anyway, if you are not from science background, nothing to worry. I will explain it. What is a how log transformations are being carried out. What's the approach of logistic regression? We are coding 0 as 1, 0 and 1, whatever our target variable is there. Remember, in logistic regression, only 2 categories are there. Okay. In discriminant analysis, you can go for more than 2 categories, but in case of logistic regression, you are not allowed to have more than 2 categories in dependent variable. In case, suppose, if you are having more than 2 categories independent variable, then the first question which you should ask is your data ordinal or not? If your data is not ordinal, then you should use multinomial regression. And if it is the data is ordinal, then you should use ordinal regression, in which again the interpretation is different. That thing also you can do from SPSS. Use of the logic curve. Now, why we are using the logic curve? I will show you some graphics. Okay. Now, see, this is a traditional tradition. We saw this thing. Okay. Ravi sir, am I audible? And our PPT is visible?
Yes, sir. Yes, sir. No problem, sir.
Now, see, please pay attention on this. Yesterday we saw that we are trying to pass a line. Okay, this is the thinking of mine only. I have not downloaded from anywhere. I have tried to explain this thing in a simple way. So we are passing a line considering the x as the independent variable and a y as a dependent variable. So this is a normal regression. Okay, but in case of logistic regression, your y is not continuous. It is breaking somewhere. Okay, so it's breaking somewhere means these are purchasers and these are non-purchasers. So I'm not in the position to apply. I'm not in the position to apply the regression analysis formula or the algorithm. Now, what is happening is this, that when we apply the log transformation, the data will get converted. The data will take this shape. Okay, data will take this shape. Now see, the data is taking this shape when I transfer it as, when I'm giving it as a log transformation. So there is a smooth straight line here and there is a smooth straight line here. So purchasers and non-purchasers. Now there is no such algorithm, straight linear regression algorithm, which can fit such data points. In such scenario, there is only one algorithm which can fit, and that is the logit curve can fit. This is a logit curve, okay, which is having this type of data. So we are trying to fit the logit curve to this type of data, and that's the reason this is known as logistic regression. Okay, and that's the reason it is known as logistic regression. So use of the logit curve, I've explained this thing with the help of the graphics. Anywhere, if you find a question, you can ask me. I don't mind. There is a question which is coming up. Chat. If you okay. So you can see some examples which have been taken, that which is considered to be the poorly fitted curve and which is considered to be the well fitted curve. Okay, this is very well fitted curve because the classification has been done very appropriately. You see this, this curve is fitting the data extremely well. But in this case there is some overlapping. See this is an overlapping. Okay, and because of this reason our curve is not fitting properly. Now what is overlapping? Let's try to understand what is overlapping. Say for example, if I'm saying that buyers and non-buyers of any particular product, this is, you can say, a very crystal you can say this is very crystal clear, that buyers and non-buyers. Okay, then I say smokers and non-smokers. That's really it's also very easy. But now see the category which I'm including. I'm saying light smokers and medium smokers. Now in this scenario what is happening is that this becomes, you can say, this becomes ambiguous, that who are the light smokers and who are the medium smokers. Now we have collected the data points in which people will feel that I am a light smoker and someone will feel that I am a medium smoker, and that's the overlapping which will start. Now when you are having an overlapping data normally, then it is known as a crisp boundary. And if it is having a crisp boundary, then in that case we are using very advanced logistic regression, that is a combination of fuzzy logic. Okay, in that scenario we are using that type of algorithm which I am teaching in machine learning, fuzzy logic. Okay, but here it's very simple. It's a crystal clear, 1 is 1 and 0 is 0. It is only the scenario when the overlapping of the data starts, your curve does not fit appropriately, or the logistic regression does not work appropriately. Okay, so what is a logistic regression? As per Andy Field, I always recommend some good books. You read the good book like Andy Field. It's a best book which you should read if you want to make a career in research or in data science. So instead of predicting the value of variable y from a predictor variable x or a several predictor x, we predict the probability. So yesterday what we saw, that what was our conclusion, that in linear regression we used to say that increase in 1 unit of x will increase y by this much unit. Okay, that example in regression which we saw, that increase in 1 unit of x will increase the y by this much unit. That was the interpretation of regression. The same interpretation cannot be done in case of logistic regression, because the functional form of the logistic regression is completely different from the linear regression. I will show the functional form. How is it working? How is it working? That also I will show. I'll how is it working? Fine. So here the interpretation is that the dependent variable is we are talking about the probabilities of happening of y, that if x is increased by this much unit, what is the probability that y will happen? Okay. So now let's try to see the difference between the regression analysis which we saw yesterday, and what is the logistic regression, how it's working. Okay. So be with me, all of you. A very small derivation is there. Even if you don't understand the derivation, not to worry. Make it sure that during the conclusion or interpretation, you are with me. So all those who are coming from science background, please pay attention, and all those who are coming from commerce background, not to worry. Make it sure that you pay the attention very clearly. Okay. Now see, be with me. There is a equation y is equal to constant plus b1 plus x1 plus b2 x2 plus b3 x3, which we saw yesterday, and this is an error term. Error term is always there in any regression analysis. Okay, error term is always there. Now, logistic regression is we are converting the same equation into the probability of the occurrence. This is exponential constant e. E is having an exponential constant, that is 2.717 is its value. But we are including here it as py is equal to 1 plus the same equation. I am including it here. I have converted the form of the equation, that is we are trying to find out the probability that y will happen or not. Y will happen or not. Okay. Now see, what will happen is, now I will change it to 1 upon 1 plus e. Okay. I will take the HCF and LCM. This e will go up and 1 plus e. So this thing has changed. Now I will name this thing as E logit 1 plus E logit. Now what is E logit? That is a odds 1 plus odds. P is equal to odds 1 plus odds. Now, so what is P? P is equal to odds 1 plus odds, and odds is equal to, if I make this thing as the function of P, then P upon 1 minus phi. I hope you recall what I wanted to see there is the probability of the success and the probability of the failure, which we started originally. Okay, from where we started this thing, we started here. I give you the example of this thing. Okay, this thing, same thing, we are trying to convert it in the mathematical equation. So this is what I had given the explanation, that what is the success divided by failure. Similarly, here also the same thing. I will again repeat the equation. Be with me. Y is equal to this equation. Py is equal to 1 plus e. Now you will ask me that, sir, why we are doing this thing? I gave you the answer that we are taking this pain because normally the data of the logistic regression or the dependent variable is having such a nature that the regression analysis cannot be fitted. Okay, I cannot fit the regression analysis in such type of data because there is a break in the data. I cannot fit. The only curve which can be fit into this is a logit curve, and that's the reason we have to take this pain. And therefore I am converting the functional form of the equation, and that is why we are running the logistic regression. Okay, so now this has changed to py is equal to 1 plus 1 upon e. The py again, it will go up. So this thing, those who know HCF and LCM, this will go here and this will go here. So E logit upon 1 plus E logit. So this is odds. This is known as odds upon 1 plus odds. If I change this equation to the functional form of odds, so odds is equal to P divided by 1 point P. So 0.80 is the probability of the success, 0.20 probability of the failure. So that's a 4 times which we saw in the example. Now restating the probabilities, we have seen this thing. So what are odds? Odd means that the probability of success to the probability of failure. Odd means probability of happening to event to the probability of not happening the event. Odds of 5:3 means probability of success is 5:8 and the probability of the failure is 3/8. any questions at this moment of time, please ask, because it is little bit complicated. Any questions? Anybody?
Why method?
Hello?
Yeah,
Anybody
any
want?
questions? Anybody?
Anybody is having a question? No. Yeah, Asha Sharma has raised the hand. Yes,
Yeah,
yes.
yeah. Asha ji, please unmute yourself.
Hello.
Yeah,
Good evening, sir.
yeah.
Sir, can you please quote some example to differentiate these two things, linear regression and this logistic regression? Any situations where we can fit this?
Ma'am, did you join late? I'm just asking that. Did you join late, ma'am?
Just in between some disturbance, sir.
Okay, okay, fine. I've already taken this thing. Ma'am, see, when you're, okay, when you're see, let me give you the example of dependent and independent variable. In case of regression analysis, if your dependent variable is running in continuous scale and the independent variable is also running in the continuous scale, then you are using normal regression. The example to this is the age and the blood pressure. Is it clear, ma'am?
Okay. Yes, sir.
Age,
Yes, sir.
age and blood pressure. And you want to see that what is the effect of age on blood pressure. Age is running in continuous scale, and blood pressure is also running in the continuous scale. Now the second example to this is that diabetic and non-diabetic, effect of age on being diabetic and non-diabetic. Okay, so here your dependent variable is running is in category. Okay, and the age is in continuous scale. So in that scenario, you want to find out that what effect the age is having on the diabetic, that with the age, does the diabetes, can you have a diabetes or not? So here, this is an example of logistic regression. Clear? Is there any other question? Asha ma'am, are you listening? Hello? Hello? Asha ma'am, hello? I think that there is too much disturbance. Anyway, is there any other question? Is there any other question? No. Okay. So let's try to move from here ahead. Now, interpretation of odds ratio is that if you get an odds ratio less than 1, all of you write down uh, on one page, because this interpretation we will have to use it in the fag end of our today's lecture. So if you get odds ratio, then the probability of event failure is more than the success. Naturally, we saw that thing. Okay. Do you want to make me recall that thing? Fine. Anyway, you just write down here less than 1. Probability of event failure is more than success. The odds ratio is more than 1. The probability of event success, the event will become successful, is more than the failure. Let's try to go on the first PPT which was there. First PPT, see this. First PPT, purchase and not purchase. Here, if your odds is more than 1, okay, if odds is more than 1, the purchase are more than not purchase. So here 1.241, if we consider purchase as success, then the probability of happening this event is more in male. If the odds is less than 1, okay, and if you want to interpret from success, I'm not talking about the failure, because failure is 0 only. If I am saying that the success is considered to be the happening of the event, now let's see what the interpretation is. If we consider purchase as success, then the probability of happening this event is less in female, because the odds ratio is less than 1. There is a question which is coming up. Yes, please, please. What is the question? What's the question? Got it, sir. Okay, got it, sir. Okay, GHRC. Okay, so let's move ahead from here. Logic way, estimated coefficients, you will get the estimated coefficients. This coefficients will be completely different from the regression coefficients which you get, and its interpretation will also be different. Okay, so now let's try to understand this thing in a very simple way, that you will get the equation a plus bx. Okay, so your dependent variable you will be writing in this form, ln p upon 1 minus p, okay, is equal to a plus bx. This is p upon 1 minus p, the success divided by failure, And what is the probability of happening? This is a plus bx upon 1 plus a plus bx. Not to worry, this is just a functional form. I'll try to make this thing more and more simple as we proceed in our lecture. But all those who want to understand this thing, that how it is working, I'm trying to explain this thing. Okay. It is using the maximum likelihood for estimation. It is not using ordinary least square method. And as it is using the maximum likelihood for estimation, it is having an iteration in the sense that it will iterate in the sense that it will try to find out the best possible fit. And that's the reason it is using the maximum likelihood estimation algorithm. uh, uh, if it is possible, I will try to find out at the fag end that what is the maximum likelihood estimation, then how it is working. I'm having possibly the video I'm having, and I'll show you the video. So keep that thing reserved, that how maximum likelihood is working to find out the best fit or a best logic curve for this type of data. Okay. Now, model estimation fit, there are some measures which are there. So yesterday we saw something that how we will evaluate that our model is good model or our model is not a good. So we used to consider something like ANOVA and t-test and all that things we were considering an R square. But now here I cannot use R square, or I cannot use a t-test, because the functional form has changed, and therefore we are using some other measures to say that is my model working appropriately or not. So in that case, the first one is the log likelihood model. The first one is the log likelihood model. Log likelihood statistics we are considering, -2 log likelihood we are considering. And the thumb rule is the lower the -2 LL value, the better fitting the model. So I'll tell you what are the thumb rules for each and every statistics, and if you get that thing, and then your model is considered the best one. Okay, so the log likelihood statistics will be generated. The smaller the better is the thumb rule in this case, -2 log likelihood. Then the model will run from the null model. I don't have to explain now what is a null model for you. I don't have to explain this thing, a null model for you. Okay, what is a null model? The null model is a basic model. Null model is a very basic model in the sense that you start that a model cannot be generated. Okay, you cannot generate any model. Yesterday we saw the same thing in ANOVA also. You are saying that I cannot make any model. So you start from the base model, and that model is known as a null model. So the logistic regression will generate first the null model. So what it says, the first step is to calculate a null model which acts as a baseline. Now, if your model new model is better than the null model, then only you will accept the model. Otherwise, you will not accept the new model. So the new model which you are proposing to the null model is known as a proposed model. The second part, they estimate the proposed model. This model contains the independent variable to be included in the logistic regression. Model fit will improve from the null model and result in lower 2LL. You will definitely get a better lower 2LL value. 2LL value is log likelihood value. Okay, you will get a better lower 2LL value. And if you get that, it means that the proposed model is working better than the null model. Also, you will assess the difference between the proposed model. You will also assess the difference between the proposed model. Now, what do I mean by the proposed model is, you will not propose one model. There will be so many models which you will be proposing to the null model. This is model 1, model 2, model 3, and you have to find out that which model is working best in this. Okay, now this is not, you can say you will do it manually, thanks to the software which this Spss, which will do all these calculations for you, and it will extract the best information which is there in this model. So this is the wonderful thing. Spss is doing all these things very wonderful. Okay, and it is giving giving the best piece of information. Now, whenever I speak SPSS, don't think that I am doing any marketing for any software, because I am speaking on many softwares like R and SPSS or State. I am not doing marketing of any software. I'm just trying to explain that what are the features in each and every software. Okay. So, okay. Then there is a pseudo R square. Pseudo R square in the sense you cannot calculate the exact R square, because I have already given the explanation that your dependent variable is now not having the same functional form as it used to be having in a regression analysis, as the functional form has changed. What is the functional form? This is the functional form. Okay, this is the functional form. This has changed. See on your screen, this has changed. Here previously we used to write y, but as this has changed, I cannot use t-test, I cannot use R square, because they are all based on that assumption that here y is continuous, and here I am saying that it is not continuous. One thing I forgot to explain you, that thing is that how logit curve will be working. Okay, how logit curve will be working. Let's try to see this thing. Let's try to see how it will be working. Suppose you get the value. Suppose you get the value of y more than 0.5. Okay, it will if you get the value when you run the logistic regression, if you get the value of y more than 0.5, it will immediately push it to 1. Okay, it will immediately push it to 1. And if you get the value of y less than 0.5, it will push it to 0. Nothing will be kept between. So there is very clear cut thing that either you belong to this category or either you belong to this category. Very clear cut. Your y will be rounded off to 1 or 0. Nothing, you cannot have any value. This algorithm will never give any value like 0.3, 0.4. It will not give any such value. Either it is 1 or 0. Now this is known as logistic regression because it is 1 and 0. Suppose you want the same thing to be in the scale of 0 to 100%. In this case, it is 0 to 1. Now I am bounding y into 0 and 100%. So that is known as probit models. These are all known as a probit model. Okay. Now, in some scenario, you may have the frequency, you may have a very less frequency in the dependent variable, like in 0 and 1, and they are all truncated models. And in that scenario, you are using Tobit model. So there are three types of brothers: logit, probit, and Tobit. Okay. Tobit you cannot do in SPSS. You can definitely do Tobit regression in R, but probit definitely you can do it here. Okay, so let's try to let's try to understand something more. So now we are having some pseudo R square measure. Pseudo R square in the sense that pseudo is something a fake in the sense that I cannot say that it is a pure R square, but it is a pseudo R square. That is my model appropriate or not? So yesterday we saw the same thing, that what is R square? R square is the explanatory power which the independent variable is giving to the dependent variable, or in other words, it is the variation which independent variables are able to explain to the dependent variable. So a perfect fit has a -2 LL value of 0.00. So all of you, please write down on one page some thumb rules which we are going to use today. That a ideal fit is that when your -2 LL log likelihood value approaches to 0.0, then you have achieved the goal. Okay, a -2 LL value should reach to 0.0. Okay, -2 LL, -2 log likelihood should reach to 0.0. Then there is Cox and Snell R square, pseudo R square. The ideal value should be 1, same as the R square. Okay, the ideal value should be 1, but you cannot have a 1, because if you are having it 1, you are nearer to God, and God has not given you that permission. So it should be nearer to 1, but the range of 0.2 to 0.4 is considered to be satisfactory in case of Cox and Snell R square, that the model is working appropriately. Then there is Nagelkar R square. Again, it should be nearer to 1. Okay, Nagelkar R square. It talks about that how the model is working. So let's try to compare the correspondence or analogy, which we say that what is total sum of squares in multiple regression? The same thing is known as minus 2LL of the base model. What is error sum of squares, which is in multiple regression? Here it is known as minus 2LL of the proposed model. Regression sum of square is known as difference of minus LL. Okay, the F test, the ANOVA, here we are using here chi-square test. Here what is known as coefficient for determination in multiple regression, here it is known as pseudo R square. Even if you don't remember this thing, this is just to make you understand the analogy which is there. Okay, so chi-square, in chi-square we are trying to find out that how our model is fitting. So we cannot use ANOVA here, and as we are not in the position to use the ANOVA, we are using the Hoshmer and Lemeshow test, which is giving us that how our model is fitting. Is it fitting appropriately or not? And that's the reason we are using this test, Hoshmer and Lemeshow. Wald statistics, again the T statistics cannot be calculated here because the dependent variable is in category, and therefore instead of T statistics we are using the Wald statistics. The interpretation remains same. Each and every interpretation will come from the p value only and significant value only, so don't worry about this thing. The transformations for the linearity, you don't require this thing. This thing is not required. This thing is not required. Okay, now let's see what is the interpretation of the exponential constants which you get. This is that when you get 0.20 as your regression as exponential coefficient, then you just minus 1 from it. 0.20 just minus 1, so minus 80 decrease in odds ratio. Again here 0.50 minus 1, 15% decrease in odds ratio. If it is more than 1, exponential coefficient is more than 1, so again minus 1, 15% increase in odds ratio. With this understanding, just remember this. I will again come back to this PPT. I will try to explain this thing again. So this is 1.7 minus 1, 0.70, 70% increase in odds ratio. So with this understanding, let's try to work on the HBT 200 data file, which has been sent to you by Ravi sir. Open that data file in SPSS and let's run logistic regression and let's try to interpret. So all of you, please start. Okay, so now probably you are ready with the data file. So now let's see how you can start logistic regression in SPSS. Okay, so this is a data file which is there. At least one person tell me that are you able to open the data file? At least one person. At least one person. Can you? Are you able to open the? Yeah, fine. That's really.
Yes.
Yeah, fine. Now listen to me very carefully. See, this is a data file which is HBAT. HBAT is a hair Black Anderson and Tatham. This is a book which is known as a multivariate data analysis book on multivariate data analysis. It is considered to be the best book as far as the multivariate data analysis is concerned. It does not give any command of SPSS, but it is just giving the interpretation of how we should interpret the things in multivariate data analysis. It is the best book. Okay, this is the example of the Hair Black Anderson Tatham. So we give all credits to him. It is their data set. You can download this data set. I'm giving you this data set. It is freely available and therefore we are using it. Okay, what this data set is, let's try to understand. The data set is that they had collected some data in which this is a data set of the America. So all of you just go in the variable view of the SPSS file. All of you go in the variable view. Please go there in a variable view. Just click in variable view. and you will be able to see the variables which are there. Okay. Now here in values, click on the three dots which are there. Okay. Here in values, click on the three dots which are there. Just click on the cell and come here. Just click on the cell and come here. A window will pop up and you will see that 0 is for all those who are inside the America and 1 is outside the America. Are you able to see that thing? At least one person reciprocate. Are you able to see that
Yes,
thing?
sir.
Yeah.
Yes, sir.
Yeah, fine. That's really nice. Okay. Now this is 0 is for those who are inside the America and 1 is outside the America. So all of you write down this thing again on one piece of paper, that what is coded as 1. What is coded as 1? Please write down on one page. 1 is all those who are outside the America. Okay, 1 is coded as all those who are outside the America. Am I right? Is it coded? 1 is what? Outside the America? Just check it. Please check it.
Yes, sir.
Okay. Now, this is a thing related to the company, and X5 is a distribution system, X6 is a product quality, X7 is a e-commerce, X8 is technical support, X9 is complaint resolve, X10 is advertising, product line, sales for image, competitive pricing, new products. All this thing is there. Fine, that's fine, fair enough. Now I want to find out that those customers who are inside the America, what they are preferring, and and those who are outside the America, what they are preferring more in this case. Okay, out of this 15 to 19 features, what is the bifurcation which is there of the services? Now I'll give you again a small example to this to make you clear that what I wanted to say is that, say for example, that you go to purchase a mobile. Okay, and there are two sets of mobile which are there, two type of brand A and brand B. Okay, brand A and brand B. So be with me that what are the features which you consider while purchasing the mobile. So someone will say that the voice, someone will say that the how much screen, wide screen is there, someone will be talking about the clarity, someone will be talking about the RAM, someone will be talking about uh, the music player, and all that features are there. Somebody will be talking about the what chip they have used and all that. Now it is not necessary that each and every variable will be affecting the decision of brand A and brand B when any customer goes to purchase the mobile. So there may be 4 or 5 variables which are highly significant for any customer to either switch from brand A to brand B or brand B to brand A. So there may be only 4 to 5 significant variables which may be working which are contributing in changing the decision of the customer. Similarly, here also we are trying to figure out the same thing, that what are the features, or what are the services, or what are the criterias of the customers, those who are inside the America and those who are outside the America. So let's try to understand this thing by using the logistic regression. So all of you go in analyze regression and binary logistics. A window will pop up, and you can also see on your screen that multinomial logistic regression is there, ordinal is there, probit is there. Okay, non-linear regressions are, you can say, less explored area up till now. The reason is the interpretation of non-linear regression is a little bit tough. So that's the reason we are not using non-linear regression. But of course, there are some, when I deliver a class in mathematics, when I had opportunity to talk about non-linear, it is in case of maths. Yes, Minali, deep, you can ask the question. Yes, Ravi sir, allow Minali Deep to unmute.
Yes,
Hello.
sir. I have already allowed to all.
Okay, fine. Yes, yes, please ask the question. Yes. Minali Deep, please ask the question. Please ask the question. Okay. So probably there is something they are not able to connect it. Okay, fine. We'll proceed from here. Is my screen visible, Ravi sir?
No, sir, it's not visible.
No, that's the same thing I thought. The same thing I thought, because I switched. No,
Yeah, I think.
I switched, and that's the reason. Okay, is it visible now?
Yeah, sir. Now it's visible, sir.
Okay, so all of you go in regression, binary logistic. All of you go in binary logistic. Okay, now just see the dependent variable. Okay, we are considering the dependent variable x4. Okay, it is in category 1 and 0, those who are inside the America and those who are outside the America. I'm again repeating again and again, in case of logistic regression, your dependent variable is in category, and only two categories are allowed. So here you can say x4 is a region, and transfer in this case x6 from x6 to x18, x6 to x18 in covariates. All of you please do that. All of you please do that. Okay, x6 to x18. I want to find out that what are the facilities which are required by the customers which are in America and which are outside the America. Okay, so x6 to x18, please take it into the covariates. Okay, and here make it forward conditional. Make it forward conditional. Why I'm making forward conditional is that it will extract the best model on its own. There are two methods in forward. One is a Wald method and another is a conditional method. Both are considered to be the very good method. So forward conditional and forward Wald, you can consider any of them. So forward conditional method is considered. Okay, so now click on options. Click on options, a window will pop up. Go for the classification plots. Hoshmer Lemeshow. Hoshmer Lemeshow is like our ANOVA, goodness of fit test, how our model is working. Click on iteration history. Okay, click continue, discontinue, click discontinue, again come back. Okay, click continue, again come back. You will be there on the original screen. Anybody lagging behind, please say that, sir, please, if anybody is lagging behind, shall I proceed? Please tell me. Okay, nobody is lagging behind. We will proceed from here. Now you click on saves. Yeah, there is a question which is coming up. Just a minute. There is someone which is lagging behind. Wait a minute. From chat box, somebody has written. Ravi sir, can you see somebody is lagging behind? What is it?
Yes. That Sumi Prasad is saying, sir, repeat.
Repeat. Okay. Okay. Sumi Prasad ji, please see on your screen. Sumi Prasad ji, please
One
see
more
on.
participant is saying, please repeat the steps.
Okay. Go. We are not in hurry. I want to teach you. Don't worry. You can tell me n number of times that, sir, please repeat it. Okay. So analyze the regression, binary logistic. Okay. Analyze logistic, binary logistic. Okay. Now take dependent variable here. Now I will change the slide, and on that basis you go on changing it. So x4 is to be transferred into the dependent, x6 to x18 is to be transferred in covariates. Okay, just see the ticks which are there. Just try to match the ticks which are there.
Hello, sir.
Yeah, please.
And what are the options there? Logistic regression options there.
Which, sir?
Logistic regression options, classification, plot, and Hoshmer,
Lemeshow.
Lemeshow, boneless feed,
And iteration history.
and regression.
Iteration history, right hand side. See on the screen, sir.
Iteration history. Okay. Yes, I can see now. Iteration history and include constant in model by default.
Yeah.
It will be same.
Same. It will be same.
Okay, sir. So I now press continue.
Press continue. Okay. See the probabilities and group membership in save.
Hello, sir. Hello. In the save option, logic is unchecked. So should we check the logic?
Logit is
Unchecked. That is this option not exercised.
no. You don't have to tick on logit residuals. No, don't tick on it.
Okay.
Okay. Now let's move ahead from here. Click on OK and you will get a first null model. That is no model. The model cannot be created. Just see in output video window, you will get that thing. A window will pop up which is there as. Are you able to see? Just check all of you. At least one participant confirm that you are getting this thing or not. At least one participant, please confirm.
Yeah,
Yes, sir,
done certain.
Okay. Don't worry. You can ask the questions n number of times, not to worry. Okay. Now there are many things which you have to see in the first table and which subsequently you will be able to remember. Now, can anybody tell me that what is coded as 1? All of you, what is coded as 1? Any one
outside America.
Very nice, excellent.
Yes, sir.
Now see, this is outside North America. Is it there? Outside North America, is it there? This is null model, and therefore no data has been given. No data has been assigned here, 0 and 0. So this is the actual observation, and this is predicted by the model. Don't worry, the model is completely wrong because it is a null model. There is no classification which has happened because the algorithm is not running. But in this scenario also, our accuracy is 59.5. Okay. So what this is saying is that that USA North America observed, it is actual data and predicted by the algorithm 0 0. Okay. So that is there is no data here. Outside North America and outside North America 119. This is 119. Now, what are the false classifications which are there? USA North America, it was the actual data, and this is by the algorithm outside North America, and this is outside North America, and this by algorithm. You are getting little bit confused. Not to worry. Let's give you the example of the real life which we are facing today, and you'll be able to understand what I'm trying to say. Okay, not to worry. That what is this confusion matrix? So the confusion matrix has taken is considered to be one of the best thing as far as to tell that is my algorithm working properly or not. So normally I take the help of the Jamboard. Okay, so let's try to see that thing. Okay, so this is the thing. Okay. Now, recently we all have came across the pandemic, and let me try to give you the example of the pandemic so that you can understand this thing. Now, a patient is having a COVID. Okay. A patient is having a COVID. All of you be with me. Ravi sir, am I audible? Am I visible?
Yes, sir. Yes.
A patient is having a COVID. Yes. Okay. The patient is having a COVID. Okay. This is first thing. Now I am using the COVID kit to check that he is having a COVID or not. A person is having a corona or not. Okay. So yes and no. Okay. So this is by kit. This is actual. So a 2 by 2 matrix will be generated. Okay. This is 2 by 2 matrix will be generated. Clear? 2 by 2 matrix will be generated. Now, what is a success for me? Okay, what is a success for me? Let's try to understand. The success for me is that a patient is having a COVID and the kit is also saying that yes, a patient is having a COVID. So this is success. Okay. What is another success? A person is not having a COVID and the kit is also saying that the person is not having the COVID. That is also a success. It is also a success. Okay. What is the failure? What is, you can say, the misclassification which has been done? It is known as a misclassification in terms of logistic regression. So a person is having a COVID and kit is saying no. So that is the misclassification. This is misclassification. Okay. What is another scenario? The person is not having a COVID and the kit is saying that he is having COVID. So this is also misclassification. So the accuracy will come from that how my algorithm is working will come from this, that how much accurate the classification has been done of the correct cases. Okay. So what we are doing here is very simple. We are calculating here is that 119 cases were correctly classified. Okay, 119 cases were correctly classified from 119 cases were correctly classified from the total. What is the total? The total is 200. So if you divide 119 by 200, you will get this figure. All of you, please check it. Are you getting it? Please check it. 119 divided by 200. Are you getting the same figure?
Yes, sir.
Yes, sir.
Yes,
Fine.
sir.
Good. Now the second thing which you should see here is that how I got this figure. Exponential. Please mute your mic. Please mute your mic. I request all of you, please mute your mic. Okay. Now the second thing which you should see is the exponential beta. What is the probability of happening to not happening? So here, divide, as we are considering one coding outside the North America, one. So all the interpretations of exponential beta will come from this side only. Okay. So you say 119 divided by 81. Are you getting this figure? Please check.
Yes, sir.
Got it?
Yes.
Okay.
Yes, sir.
Now this is your beta coefficient. Its interpretation we will see later on. This is T statistics and this is SIJ value. Okay. SIJ value is, yesterday we saw that if your P value is less than 0.05, this person is able to pull the string or it is able to contribute. And here the desirable value is that your P value should be less than 0.05. So this is a null model. Null model is not working. Null model is having only the accuracy of 59.5. Let's proceed from here. Variables in not in the equation. So there are no variables in the equation. Not in the equation. Not a single variable is there in the equation. Can you see? This is variables not in the equation. Now just go scrolling. Just go on scrolling. Are you able to see variables not in the equation?
Yes, sir.
Fine. Variables not in the equation. So no variables have been made. The equation is not made in null model. Now the first model beginning block starts. Okay, when we run logistic regression, minus 2 Loglikelihood acts as a residual sum of squares. So here, as we are not giving anything in the null model, everything is residual. हमने model, there is nothing in the there is nothing in the model, there are no variables in the model, and therefore everything is residual, and therefore when you assign some variables to the model, two likelihood will start decreasing. Wait for a minute. Now let's see, are you getting this type of thing? Check beginning block -2 log likelihood. Are you getting this thing? Step 0, in step 0, 269. Are you getting this thing? Check, all of you. This is the base model only at present.
Yes, sir.
Okay, so in the next model, your -2 log likelihood should go down. Is it clear? All of you are with me? All of you are with me? Fine.
Yes, sir.
-2 log likelihood should go down. Okay. Now see Cox and Snell R square. How much is it? What is the explanatory power of the model? The explanatory power of the model is 0.565 and Nagelkar R square is 0.763. This is base model. Okay. Now what is the residual sum of block is this will see later on. Now see in block 1 what has happened. Is -2 log likelihood going down? See in the iteration history. See in the iteration history, is it going down? Iteration history, all of you check. Is it going down?
Yes, sir.
It's going down, and therefore it is very nice. So it means that the 7th model, the model number 7 is the best model because the iteration process has stopped on its own. The iteration process has stopped on its own on the 7th model. Fine. Anybody lagging behind, please feel free that you can tell me. Feel free to discuss. Okay, feel free to discuss. Okay, please repeat, who is this? Please repeat, who is this? Please repeat, who is this? Please repeat. Yeah, Babita ma'am, Babita Yadav, are you on tracks? Babita Yadav, Babita Yadav, are you on tracks?
Babita ji, please, you can unmute your mic and ask to the sir.
आप पूछ सकते हैं मैडम, क्या है आप बोल रहे हैं? प्लीज रिपीट. कहां से रिपीट करना है मैडम? ठीक है, कोई बात नहीं, चलिए आगे बढ़ते हैं. अब यहां से आगे चलते हैं. नाउ यू विल बी ऑल्सो गेटिंग दिस थिंग. सी ऑल ऑफ यू, आर यू गेटिंग दिस थिंग? Block 1 method forward stepwise conditional. Are you getting this thing?
Yes, sir.
All of you, please check it. Okay, now see what the figures are. The first thing which you should see is the SIG value. This should be less than 0.05. Is it less than 0.05 in step 7? Just check it. The model number step 7. Is it less than 0.05 in step 7? Is it less? Fine. When we started with the base model, our chi-square was 79.452. In step 2, we were able to achieve the chi-square. Here our objective is to increase the value of chi-square. Okay. So now 79.452 plus 36.938. Are you getting 116.390? Check. Do the addition of model and step. Are you getting it?
Yes, sir.
Okay. Eventually the addition in the model will go on decreasing. Okay. So 116 plus 14, you will get 131, then 21, then 9, then 4, and ultimately very less chi-square will be added. And when there is nothing to add to the model, the iteration process will stop. So 170.90 is the value of chi-square at which the model terminated, or you can say that the model number 7 is the best model. Okay, this is the best model as far as the extraction process is considered. Okay, now see -2 log likelihood in model summary. Is it decreasing? Yes, it has decreased drastically. Is that decreased drastically? See, you probably you must have got 99.
Yes, sir.
Got it? Your Cox and Snell R square, the explanatory power of the model from 0.328 it increased to 0.57. Is it correct?
Yes, sir.
Yes, sir.
the Nagelkar R square increased from 0.44 to 776. Is it good?
Yes.
Yes, sir.
Okay. In this model summary, -2 likelihood value should decrease and R square value should increase. Okay. Likelihood should always decrease and R square should always increase. Got it? Okay. Now we will go from Hoshmer and Lemeshow test to see where the model fits appropriately. Is it clear? Are you on this screen, all of you? Anybody lagging behind? Please tell me. Nobody? Okay. In case of Hoshmer and Lemeshow test, you have to go reverse. You have to start from 7. And whenever your p-value is more than, in case of Hoshmer and Lemeshow test, wherever your p-value is more than 0.05, you have to stop. Is it clear? I am again repeating. In case of Hoshmer and Lemeshow, we have to start from the bottom. That is from the reverse, from here. And whenever the p-value is more than 0.05, you consider that model to be the best one. Okay, all of you be with me. Here the value is less than 0.05. No, move ahead. Here the value is more than 0.05. Stop. The model number 6 is the best model. Yes, please tell me. Yes, please tell me who is that? Somebody has dropped some query in the chat box. Yes, what is the query? Please tell.
No, sir, I said that on that at second last it will stop like at 0.247.
Yeah, at 0.247 it will stop. At 0.247 the algorithm has stopped. Okay, suppose just for an example, here also, yeah, Rupam Mukherjee, please ask the question. Rupamji, please ask the question.
Hello, sir. Actually, I just want to know that in normal cases, when we check the null hypothesis, we make a sort of check that whether the p-value is less than 0.5, and that is actually
0.05.
Sorry, sir, and that gives us the model good fit. But here we are seeing that it is, if it is greater than 0.05, then it will be a good fit. Sir,
Right.
what is the reason behind it? What is the difference?
The reason behind this thing is that we are using here the maximum likelihood estimation, and in maximum likelihood estimations we are seeing that which is the best fit which we are getting, and therefore we want to move our data out of the points. It is rather, I will say, I am also beating around the bush. I am very clear that it has been suggested by Hoshmer and Lemeshow that wherever my p value is more than 0.05, you have to stop. This is the thing which has been suggested. Now, in many scenarios, we have seen that we want that the model fit should be less than 0.05, but it is only in case of logistic regression we go with this. The second thing is, even in case of the variance test, and in case of normal distribution, our null hypothesis is also such you can say such computed that what is the null hypothesis in normal distribution? That our data is normally distributed. In case of variance, all variances are equal. Now you will all say me that normally you have told me that null hypothesis is null and void, but here this is the concept that they have suggested that you go for this way. Okay, I will also search for it, that why Hoshmer and Lemeshow is suggesting that you go this way, but normally it is. Similarly, I also seen the same thing in case of structural equation modeling also. It's the same thing. If anybody is having something to put here, I don't mind. Please, anybody is having some thought on this, please discuss. No? Anybody? Feel free to discuss. Okay, so let's move ahead.
And sir, just another question I had regarding this issue,
right,
that whenever we are checking the explanatory power of the model, then in case of normal regression model, what we do is actually R square or adjusted R square. But here we are getting some pseudo R square values regarding that is the Cox and Snell and Nagelkar R square. Sir, why the values are different in these two? the Cox and Snell values, are there in different scales, or what is the difference we are getting in values?
No, the reason is that the functional form of the equation is different. The R square equation which has been made, it has been made for a normal regression y is equal to a plus bx. If you want to read more about this R square, you can use the formula. You can use it is given in Damodar Gujarati that what is the formula of R square, and this is not possible to use the same formula in case of logistic regression. As in case of linear regression, we are writing y is equal to a plus bx. This is the formula. R square formula is dedicated for this type of equation. But in case of logistic regression, we are using ln y upon 1 minus y a plus bx, and that's the reason R square formula is not applicable here. And therefore, we are
Sir,
using.
I just wanted to know, I understand this, but the question is, why the values of R square, pseudo R square values, that is the Cox and Snell value and Nagelkarke R square values are different?
There are many statisticians who are coming out with the different formula. If you are working on the test of normality, you very well know that there is a Jark-Bara test, there is an Anderson-Darling test, there is Shapiro-Wilcoxon test, there is a Kolmogorov-Smirnov test, there is a Lilliefors criterion. So everybody is coming out with the new formula. So this is, you can say, the contribution of the academician, that Cox and Snell has said that you calculate R square this way, and the Nagelkar has said that you calculate this way. There can be the difference in both the scenarios, but it can never be a scenario that both of them you can say converge to a same thing. It is never possible. It is just like the thing that that you do the COVID testing with one kit. One is saying that yes, it is okay, and second is saying it is not okay. It is bound to happen. It is bound to happen, and we cannot say that they will converge, that you will get the same values. It is not possible. It is depending upon some formula. Okay.
Okay, sir.
So let's try to see now in step one what has happened. In step one, the correct classification. Now, what are the correct classification? The correct classification is this. Just see on the screen, 52 are the correct classified cases and 99 are correct classified cases. These are all misclassification. So accuracy in the first step was 75.5, which increased to 88.5 in the step 7. Are you getting all of you same result? Please check.
Yes, sir.
Please check.
Yes, sir.
How many misclassified cases are there? How many misclassified cases are there? 7 and 16 here. Okay. Okay. Now, what is the difference of accuracy in steps 6 and 7? How much is the difference in accuracy? 2%. From step 6 to step 7, how much is the difference in accuracy? 2%. Now, which model I will select? Step 6 or step 7?
The one with the more accuracy?
Okay. Okay, that's the answer. Is there any other answer?
6, sir. 6.
Why 6? Now, there is something which is known, concept is known as a parsimonious model. You should always have a rule of 80-20. Okay, what is the rule of 80-20? The rule of 80-20 is that you should identify 20% such variables which are having explanatory power of 80%. I'm again repeating. You should identify 20 such variables which are having explanatory of 80%. Okay. Now, just imagine you are having 80% such variables whose explanatory power is 20%. Which model is good one? The first one. So if your accuracy is just increasing by 1% or 2% by including the additional variable in the model, just drop the model, keep the model simple with less number of variables. Okay, you cannot make a regression equation which is having 10 to 15 variables, and you cannot make a regression equation which is having only one or two variables. At the most you can have 3 to 6 variables in your regression equation. Now, why I am saying this thing is that when you go on adding the variables in the model, classification accuracy will always increase. But the you can say that these variables are not so much significantly contributing, and therefore we will try to find out which is a variable which is not so significantly contributing in classification. For example, in case of brand A and brand B mobile, which the example I have given, uh, you all, when you go to purchase a mobile, you are all worried about the sound, the clarity. Are you all worried about that which chip the company is using, which chip company is using? No, we are not worried about that which chip is using, because it is not a matter of concern for me, and therefore this variable is not contributing in my decision power. Okay, and therefore this variable I will not consider. So I will always consider those variables which are significantly contributing in my decision power. So next thing, now go all of you, scroll down, and you will get what are the variables which had been considered in the model. So in the first step, only X13 was considered. Are you on the same screen which I'm there? All of you are there on the same screen. All of you, please check variables in the equation.
Yes, sir.
Okay. So in step 1, X13 was included. X17 was included in second step. X12, 13, 17 were included. In sixth step, we are having X6, X7, 11, 12, 13, and 17. And in step 7, X6, X7, X8, 11, 12, 13, 17 are there. Please, all of you write down on one page 6, 7, 8, 11, 12, 13, 17. Okay, all of you. And let's go back there and try to find out what these variables are. So X6 is what? Product quality. It is significantly, it is contributing that we will be able to say that the customer is demanding a product quality. X7 is e-commerce, technical support. Then what is another after X8? What it is? X11, product. X11 product line, sales for image, and competitive pricing. Okay, so how these variables are contributing, let's try to understand. First of all, let's see the p-value of all of them. Is the p-value of all of them less than 0.05? Naturally it will be less than 0.05, because our plane is running on autopilot. Okay, as we have said, forward conditional, then it is a autopilot mode, and it will try to find out the best model it will try to figure out. Okay, best model it will try to figure out. Now this is 0.006, 0.4 exponential. This thing is how this is interpreted. If you recall, I had given you that explanation that -1. Okay, -1. So let's talk about X6 -1. Okay, so 0.442 minus 1. Okay, X7 0.212 minus 1. X8 1.421 minus 1. Now let's take the case of X13. X13 value is 1.667 minus 1, which means that this variable is contributing. Competitive pricing is contributing 66.7% towards the outside America. Competitive pricing is demanded by those customers who are outside the America. 66.7%. Is it clear? Now let's talk about 4.612. The largest contribution is coming from X17. X17. So 4.612 minus 1. 361 percentage. This is contributing towards that a customer is outside the America. Okay, or in other words, the probability that that this variable, it is 4.61 times in this case that a customer is outside America. So these are the all your interpretation is coming from what you have coded as 1. Now let's see another case. 0.442 minus 1. What it will be? Please, anybody tell me. 0.442. What it will be? Please tell me. Minus 1. What it will be? 0.442. What it will be? Minus 1.
Minus 0.5.
0.778.
Minus minus 0.56. Okay. Minus 0.56. Can anybody tell me the interpretation of this? Now it's your time. What will be the interpretation? It is minus. It is not contributing towards 1. But we cannot write anything related to 0 because we have coded 1. So what we will write is that x6 is contributing minus 52 percentage towards the happening of event 1, minus it is negatively contributing. It means that this event will not happen because of x6. So whatever which is happening, what are the variables which are contributing towards 1? X8, see x8, then x12, then x13 and x17 are contributing towards outside America. What are contributing towards in America? X6, x7 and x11. They are contributing towards they are contributing towards inside America. Okay, now let me try to make the equation. Just a minute. Okay, just a minute. Okay, now let's try to make the equation from this. Let's try to make this equation. I'm trying to make the equation from from the step 7 only. Okay, now which is the variable which is not there in step 6 and step 7? X8. Okay, so x8 contribution is considered to be very less, and therefore it has been removed. It has not been considered in step 6. So we are making the equation which is very simple. Step 6 is a simple equation, and step 7 is having one more variable. We don't mind because our accuracy is increasing just by 2%. Okay, so you can take a call. You want a 6 or 7. Now what will be the equation? So the equation will be with me, log p upon 1 minus p, constant. This is a constant which is there, minus 6.483. Sorry, I have done some mistake. It will be what? How much is it? What is the constant? Can anybody tell me the constant? Minus, how much is the constant? Please help me, all of you. Minus
483.
6.483 is a constant. Okay. And how much is a x6? How much is x6? Please tell me. X6 is minus 0.816. Okay. Minus 0.816 asterisk. Sorry, 816 asterisk into x6. Okay. Just all of you check it. Are you getting the same thing? All of you are getting the same thing. Check it. All the coefficients, please check. Please check, all of you.
Yes, sir.
Okay. Now, when you insert the value of x6, x7, x8, x11 and x12, you will get log p into upon 1 minus p equal to some value. And that you will have to convert it into anti-log and p upon 1 minus p, and that way you will get the probability. What is a p here? P is the probability of the customer being outside North America, as it is coded as 1. You don't have to do all that thing because you have already done by using the exponential coefficients. You don't have to do all these things. It is just giving you a probability. You can take any arbitrary value of x6, x7, x8, and it will tell that this customer is inside the America or this customer is outside the America, and that is the concept of classification. Any questions up till now, please ask. Still we have to go ahead. Any questions, please ask. Please feel free to ask questions. Any questions? No? Now, what will be the scenario if in our case, our independent variable has 1, our if our independent variable has one or two categorical variables.
Sir,
Yeah, please ask the question.
sir, can you just repeat that out of the two models, the sixth one and the seventh one, we can select any of the models?
Okay, out of 6 and 7, the accuracy is just
Because
increasing.
in the last slide, we just discussed by 2%. Yes, sir. Yes,
Yes,
sir.
yeah, just by 2%.
Yeah.
Now see, by
Yes, sir.
increasing the variable, if your equation, if your accuracy is just increasing by 2%, it is not necessary that you include the variable. Make your life simple, make the simple equations simple. Okay. But if there is a drastic change by including the variable, then definitely the model, then definitely you will have to include the model. You will select 6 or 7. Nobody can tell you. It is a researcher's call that you have to consider. Okay, researcher's call. The statistics have said that you should consider the 7th model. But you should go for 6 or 7. It depends upon the researcher, because by including the variable in the model, only the classification accuracy is increasing by
Yes, sir.
2%.
Yes, sir. Okay. Thank you, sir. Thank you.
Okay, so now what to do when we have categorical variables, that is x5. All of you see x5, just all of you see in x5. Go in variable view and see what is there in x5. All of you please check what is there in x5, and one of the participant please tell me what is there in x5. What is there in x5? What is there in x5? Please participate, all of you.
Distribution system.
No, x5.
Zero
Sorry.
is
Sorry. Wait.
distribution system.
Wait.
Distribution system.
Yeah. Fine. And what is x3?
X3 is the farm size.
Farm size.
Okay. So we will be working on x3. Okay. So please tell me what is coded as 1. We'll be working on x3. What is coded as 1?
Large. So one is large.
Those
Large.
those
500
companies
plus.
those companies which are having more than 500 plus 500 plus employees, and 0 is coded as how much? 0 is
Small.
coded as small.
02499.
0249. Now I want to find out that the logistic regression which is applicable on the entire data, is it applicable same is applicable on small and large firms also. So here I am bifurcating my equation. I am trying to find out the effect of x3, which is a categorical variable, in on my logistic regression. So all of you go back to the regression. If you don't want to change anything, be with me, all of you. Remember, if you don't want to change anything, you can just click on this part, and it will tell me the history of the commands which I am running in the regression. All, please mute your mic. Okay, just click on it, and again a window will pop up. Click on that logistic regression, and you will be able to get the same window again. Okay, now here x3 was not included previously. It was not included previously. So select x3 from here and transfer it into covariates. Done? Please, if it is done, please tell me.
Sir, please repeat.
Okay, if you're getting confused, again go from analyze, regression, binary logistic, go from there.
Yes, sir.
Done? Again a window will pop up in which the x3 was not included previously. Done? Transfer this x3 into covariates. Okay, okay. Now click on categorical variable. Click on categories. Done? Done? transfer X3 from covariates to categorical covariates. Anybody lagging behind? Please feel free to tell me that, sir, please, anywhere if you are lagging behind, please tell me. Okay. Okay, just click on continue a window. This now X3 will, the status of X3 will change to category. Done. Has the status of X3 changed to category? At least one participant
Yes,
tell
sir.
me. Yeah. Now, again, everything is remaining same. Just click on OK. Just click on OK. Just click on OK. Just click on OK because everything will remain same. The additional new thing which has came up is, just scroll down again, the logistic regression will run. A new thing which will come up is the categorical variables coding. All those who are working on dummy variable analysis, the dummy variable has been generated by the SPSS on its own. It is also known as hot encoding. It is also known as hot encoding in the language of machine learning. These are known as hot encoders in machine learning language. Okay. Also known as dummy variable analysis, also known as a categorical analysis. Okay. So are you getting this categorical variable codings? Please tell me, all of you. Getting?
Yes, sir.
Yeah,
Yes, sir.
fine. One more additional step has been generated. Okay. And now you can see the classification accuracy has reached to 93%. Okay. Has it increased? We have pushed our classification accuracy to 93%. And a new model has came up. You can see X31. Okay. X31. Now X31 means the category 1 is significant here. 1 is for the large companies. So for large company, this model is X31, X6. All of you please check. Are you getting this thing that's in step 8? Same thing.
Yes, sir.
Okay. And now what will be your equation? See, here you just have to see, just focus your light X31. So in X3 only those companies which are large 5 has it is coded 1. So large companies values are only considered here because 0, because we are comparing everything from the baseline. Okay, and 0 is not significant here. Only the large companies are able to classify. 0, those small companies are not able to classify that the inside that the customer is inside America or outside America. I again repeat, small companies are not able to classify that it is inside America or outside America. It is only the contribution which is coming from large companies that were inside America or outside the America. So thank you. Now we open the question answer rounds. This is all about the logistic regression. Please feel free to ask as many questions as you want. Please feel free to ask questions.
Yes, anybody wants to ask the question? Yes, Rupamji.
Hello, sir.
Yes, yes.
May I ask one question?
Yeah, please, please.
Hello.
Yeah. Please ask.
Okay. Sir, just a query. I am Dr. Rupam Mukherjee. Sir, in case of logistic regression, one thing we also do is that is sometimes called the marginal effects. And I think that part is easily been done in Stata. But is it possible to do the same exercise in SPSS?
Marginal effects which we are doing here, it is not possible here. Marginal effects is only possible in Stata. I can show that thing, but it is not possible here. The contribution of each and every variable which you are talking about, no?
Yeah.
No,
For 1
that's
unit discrete change in each and every
yeah,
variable, what is the resultant effect?
yeah. It is not possible here. I can understand. This is not possible. That if the variable changes from this thing, you can get the slope from it. So here, possibly here you will get the negative slope. Here you will get the positive slope, but that is not possible here. That is not possible. That is only possible in Stata.
Yes, sir. Yes.
So when
Okay,
when I give the lecture on Stata, it is also giving marginal effects and marginal plots. Yes, it is giving it. It is giving it.
I think in Stata, sir, we can also show the receiver operating curve, the area below the ROC. That can also have some discriminative power to show how the model fits good.
See, Rupam sir,
Yes.
this is a lecture related to the social science. Okay, and definitely I have not included the ROC here. You are quite right that the ROC can be computed, because the concept of ROC is more related to the machine learning, that how well the algorithm is working. It is a operating receiving characteristics, and it should be nearer to, and that's the reason I have not considered that the accuracy classification score. The same lecture if I am giving in machine learning, definitely ROC can be computed. Definitely ROC can be computed. You are right. You are perfectly right. You are perfectly right. Is there any other question which is there? Is there any other question? If you want, you can plot the ROC curve from here, all of you. It is there on your screen. I can show you. This is the ROC can be plotted from here. Okay. So let's try it. That is X4 is a region. Value of the state variable is 1, and here from here I can take it X6 to X18. How is it performing? Test variable, click OK. So you can see possibly just a minute. Okay, just a minute. It's processing. See, this is the ROC curve. It is there. So these two are not working properly. But this is, sir, Rupam sir, this is not related to the model. This is related to the variable, and that's the reason I have not included how the variables are contributing. Okay.
Yes.
But definitely this can be done in Stata. This can be done in Stata. It can be done in Rettel. Okay, it can be done. Any other question? Please ask.
Thank you, sir.
Any other question? Please ask. Feel free to ask questions. As many questions if you are having, please ask. I don't mind. Please ask. Please ask. Are you able to understand any queries? If they are there, please ask. No? Ravi sir, ask them if
sir, actually you are teaching so well. I think you don't left any query for them to ask. I think so.
Okay, so let me show you something. That is, we have came out with the teachers training program. Okay, myself and Hitesh sir are you can say just like Jay and Viru.
Jay and Viru. Yes, sir.
We are Jay and Viru. So the softwares which we are teaching are, these are the softwares which we teach: SPSS, Jamovi, Minitab, MATLAB, Gretel, Views, Amos, DOE, Design Expert, Atlas.ti, Tableau, Microsoft BI, production softwares, Orange, and all the softwares. Hitesh sir also knows some horoscope softwares also. So we have not left anything unturned. Okay. So these are all basic data analysis. So basic data analysis we are giving in 4 softwares, that is SPSS, R, Minitab, Jamovi, and Stata, in which we talk about data coding, management, transformation, graphical representation, normality testing. So this is basic testing: parametric, correlation, regression, and non-parametric. What you have opted for is the advanced statistics. Okay, so in advanced data analysis, it is given through SPSS, R, software, Minitab, and Stata. You have seen multiple regression analysis, and today what you have seen is logistic and discriminant analysis. Hitesh sir will be talking about next 2 days on exploratory and confirmatory, cluster, conjoint. This will be taken by us. What other things are multivariate analysis are ANOVA, ANCOVA, MANOVA, MANCOVA, SPANOVA. These are all types of ANOVAs. So 2 days can be just dedicated on ANOVAs. Structural equation modeling, we are talking about, we give this lecture on platform like Spss, Amos, Idenco, Stata, R, and on this Jamovi also, using Jamovi also. So in this case, we talk about confirmatory factor analysis and structural equation modeling using these softwares. If you talk about that time series analysis, all those who are interested in finance and time series analysis, so the program has been divided into 3 phases. The first phase is the basic econometrics. This we are giving with EViews, Gretel, R, and Stata. Advanced level econometrics, we are giving it with the topics which are there are ARIMA, co-integration, VAR model, vacuum model, Garch family, variance decomposition, simultaneous equation method. And in very advanced level, we are talking about the panel data analysis, that is panel VAR and panel vacuum. All those who are interested in machine learning. So machine learning, we are giving with Orange, R software with Carrot package, Rattle package. My book is available on Google on Rattle package. Also, the training is provided on Python Skykit. Recently, my workshop is going on in Mumbai on Python. IES MCRC College. At present, the workshop is going on this only. The data analysis, machine learning using Python. So in this, we teach descriptive analysis, inferential statistics, regression analysis, supervised learning, unsupervised learning, what is boosting, bagging, image analytics, text analytics. So this is related to machine learning. All those who are interested in engineering research, those who are pursuing engineering, then we are teaching something with the help of Minitab. My book is available on Minitab. And design expert. This is a totally different type of research in which we talk about the experimental design, full factorial design, fractional factorial design, improving the design, response surface design, mixture design, Taguchi design. Those who are interested in quality management using Minitab, this is related to how you implement Six Sigma in your companies. Then we give it by using Minitab. All those who are interested in social network analysis, that social network analysis like Facebook and Twitter data, not the content data, how the network is operating. Then we are talking about, then we are giving it by using Gephi and Netminer, in which we talk about this statistics, analyzing networks, filtering networks. And other topics which we teach are data envelopment analysis is using frontier software, analytical higher process using Topsys approach, meta-analysis, neural network, propensity score model, and physics logic. Thank you all of you. Any questions? Ravi sir, over to you.
Any questions? Yeah, Ravindraji, please ask.
Yeah, sir. Sir, first of all, my compliments to you for explaining logistic regression in a very nice and clear manner, sir. Your method of teaching is really very unique and very nice. Congratulations from my side, sir.
Thank you.
Yeah, I have one observation, sir. I have one question. So just now you showed about ROC model. So can you throw some light on this ROC model, sir? Why do we use ROC model, and what is the purpose of using ROC model?
Yes, definitely.
And then other question I have is, kindly explain on ridge regression. What is the basic difference between ridge regression and logistic regression?
Okay, fine. No, not ridge regression. It is normally, it is the differences between linear regression and lasso and ridge regression. Okay, so let's start with the first thing. The first thing is I'm clearing this thing. Now we have already discussed one part, and that one part is that if I am having a null model, so what is the probability of happening the event? It is 50-50. Okay, ROC, this is 50. Okay, so this is considered to be the base model. This is based model. Okay, this is the base model. This is based model. Normally here we keep specificity and here we keep sensitivity. These are all related to the accuracy of the score. These are all related to the accuracy of the score. Okay, so this is the line of no model. When I'm offering a model, that is this, you can say the null model. This is a null model in logistic regression. Okay, this is null model. But when I am offering any model, the proposed model, its accuracy should increase. So say for example, if in case of, in our case, in step 1, what is the ideal situation? What is the ideal situation? The ideal situation is which nobody can reach, okay, in which the classification accuracy reaches to 1. This is the ideal scenario. Wait a minute. This is the very ideal scenario which nobody can reach, in which the classification accuracy is 100%. Classification accuracy is 1. Okay, you cannot reach there. So now what is happening is you may get a different type of view. So first thing is the first iteration, you got something like this. The second iteration, it goes nearer to the ideal value. The third thing, you again go to the nearer to this. Okay, but there can be some scenarios in which the model gives some confusing figures, that it is good up till here and again it is here. So in that scenario you have to take a call that which model you will consider. So this is an ROC comparison, is known as a receiving operating characteristics. Okay, Rupam sir, do you want to throw some light on it? You can talk about this thing. Rupam sir. Rupam sir. Rupam sir, do you want to throw some light on this?
Rupam sir, are you there?
No.
Yeah, I see. Again, sir.
Rupam sir. No? Okay. Now let's talk about the lasso and ridge regression and what is the difference in them. So let me show you the PPT of the lasso and ridge regression, which is there. Now the regression which we are using is normally 100 years old. Okay, and this regression is not allowed. This regression is not allowed. Okay, I'll give you some concept of why lasso and ridge is required and what problems what problem can arise if this happens. Okay. All of you know the Fukushima power plant. Okay, Fukushima power plant. Now they plotted something. They plotted on the x-axis, they gave something that is a magnitude of the earthquake, and on y-axis that was a probability of happening the event. Now they computed something that the probability of happening the event of the probability of earthquake happening of the 9 scale is next to impossible. Okay, they have seen that thing, that the probability of, they collected the data of last 500 years and something, and therefore the Fukushima power plant was designed with the power of considering this as 8 Richter scale. The safety limit was considered 8, and as soon as you can say the power plant was made, within 2 months the Japan earthquake hit was more than 8. Now what went wrong? What went wrong was that it considered the regression which was normal regression. Uh, it did not consider the proper, you can say, the regression in which all the points were considered, and this is known as a underfitting of the curve. Okay, then what is overfitting? Okay, what is overfitting? There can be sorry, this is overfitting. See, this is normal regression which they consider, and actually this should be there. Okay, what is another explanation of underfitting? Another explanation of underfitting is that the body mass of the insect is considered and the speed with which they can run is considered. Now if we go with this, then the body mass, with the increase of body mass, These animals are able to run very fast, but the elephants, their body mass is so much, but they are not able to run. And if I fit the linear regression in this thing, then this linear regression is not going to work. And therefore what the new researcher found is, they found something which is known as bias in the estimates. To remove the bias in estimates, what they came out with a very novel concept. The novel concept was that to assign the penalty, to give the penalty to give the penalty if the regression coefficients are taking the extreme values. If, see, to give the penalty means if b0, b1 and b2 are taking the extreme values, then to penalize them, to give the penalty value. Now how can I give the penalty value? This was a normal regression which we used to do, but the penalty was offered by inserting the another variable, and that is c b0 square, b1 square and b2 square. This is called the Ridge expression. Now then what is the difference? In Lemeshow? In Lemeshow, the same thing, instead of square, they have considered as the absolute values, as absolute values. Just a minute. See this thing here. This is Ridge, in which we are penalizing the equation by square. In Lemeshow, we are penalizing the equation by absolute values. We are taking the absolute values, and when we take the combination of Ridge and Lemeshow, it is known as elastic nets. So you should be aware about elastic nets if you want to work with the industry data. Okay, and this Ridge and Lemeshow regression cannot be done in SPSS at present. It is only possible in Orange and R software. So this is my answer. Any other question is there? Please ask.
Is there any other query?
So thank you very much, sir, for giving explanation on ridge regression. Sir, do you also teach smart PLS, sir, for doing structural equations modeling?
Yeah, I do that also.
Sir is the master of the. No, we have seen. Sir, I think no questions left for ask, sir. Everybody is satisfied, I think, sir. And the chat box also says, sir. Everybody is saying.
Those who want to attend my, again repeating, those who want to get the notification of my lecture, they can just send me on my mobile number hello, and I will send the WhatsApp link. You can join in my channel if you want. Okay, it is not compulsory. You can join there and you can get the notification of the programs which are being organized all over the country. So thank you once again to Ravi sir and to INSPIRA'S and our senior Modi sir for giving me the opportunity. So we will be meeting on now directly on Saturday.
Yes, sir. Yes, sir. Yes, sir. Tomorrow and day after tomorrow will be as sir said, Viru will be present. Yeah. Professor HITESH PARMAR, sir.
Okay. So thank you, all of you. Thank you.
Thank you so much, sir. Thank you so much, sir, once again for the fruitful session, sir.